The purpose of this video is to take you from block-based programming environments like Scratch into written-based language programming like Python. Now, what you probably don't realize is that Scratch has got you very much on the way to writing your code. It teaches you the structures, and actually, without realizing, things like indentation are actually part and parcel of using Scratch. We're going to go through a few of the features of typical programming in most languages, because although the words used within programming language may vary, so between maybe C++ or Java or Python or Pascal or any other programming language, the actual structures are generally fairly similar. So what we're going to do is we're going to go through a few of the features today. So we're going to have a look at how indentation works. This is particularly important for Python. Not all programming languages use indentation to show what is inside other things, but Python does. We're going to look at variables and how they're covered in Scratch, and then how that works in Python. Then we're going to look at some of the loops, things like forever and repeat, and things that you would have used in your programming in the past. And then finally, we're going to finish with conditions and some generation of random numbers. Now, although it sometimes feels quite daunting to go to a written language, actually, once you have some of the structures in place, it's just a case of putting them together, putting the blocks together like you do in Scratch. So once you've learned a handful of those things, there's an immense amount of programming that you can actually create by just knowing those few elements. So let's start at looking at indentation, because actually how we lay out our code is possibly the most important part with Python, and it's sometimes the thing that people struggle to get their head around to begin with. So indentation is basically something where if something happens inside something else, so something happens each time it goes through a loop of a repeat. Each time it goes into a condition, maybe the stuff that happens if that condition is met goes inside that condition. So in a basic example, as you can see on the screen here, we've got some Scratch blocks that have a block first, say something, then it repeats saying something else 10 times. So moving on to Python, if we kind of copy over the blocks, you'll see that the bit that says say something else, which is inside that repeat, is pushed inside the block. And you can see where the green arrow is, it kind of sits inside that. Now that is called indentation. If we now move on to show you that roughly in code in Python, it looks something like this, so that you have a line that says print say something at the top. You have the top part of the block for the repeat, which we'll go on to repeats later, but that for I in range 10 is basically means repeat 10 times. And the bit that happens those 10 times is pushed in, and we use the tab key, which is a button next to the Q. It's got the arrow and the line, if you look at your keyboard, and that pushes everything in a fixed amount. Now, the thing with Python is even if you're out by kind of one space, it thinks that if it's not exactly lined up, it thinks that it's in a different loop. And if it's not there, you may get what's called an indentation error. So when you run your code, you may get a warning that pops up in your results, or an error that pops up in your results that tells you that there is an indentation error. And that simply means that something isn't lined up as it expected to be inside another block. Now, in more complex examples, you might find that things happen inside other things that then happen inside something else. So in this case, you can see that there's a forever loop that goes around the outside. Things are pushed inside it, so then we've got a condition that's pushed inside it. And then the bits that happen in those conditions are pushed in again. So you can sometimes end up with 1, 2, 3 or more tab bits going inside each other. And you can see those red lines. You'll end up with bits that aren't the full length inside going inside. So you can see that second condition is much shorter, where it says if key space is pressed. So the indentation of those two blocks inside are inside, they should be tabbed in basically 3 times. Okay, so you'll have those going well inside, And if you want to continue afterwards, you might have to come back out. If I just go back to this one here, if I wanted something to continue after the repeat block, I would simply have to come back out in line with the for I in range. And it's kind of the same as the bit that happens before it. So the print saves something you'll see is lined up with the for. If I want something to sit in the block below it, I would come back out and the start of the word should be lined up with the for of the for I in range. So in terms of variables, so variables are things that they're basically stores for information. So quite often in games and things, you might have a variable that holds a score. You might have a variable that holds a time that counts down once every second. There's a whole range of things that you might hold in variables, and it can be even more complex things like lists of things. In Scratch, the block for setting a variable value is set, and then you choose which variable it is, and you put the value in that's going to do it. Now in Python and most other languages, we use the single equal sign to assign a value to a variable. Now you may then think, oh well, what happens if I'm doing a sum? You know, we're quite often used to having a single equals is kind of the result of a mathematical sum. Now in programming, the single equals is assigning a value to something, usually a variable. Okay. If I wanted to compare something, then so if I wanted to say if my age is equal to 18, then send a birthday card with 18 on it. Okay, so the if equals 2. Now the equals 2, it may sound like it should be a single equals, but it's not. We're saying if something matches something else, and in programming typically we use a double equal sign to say, does it match something else? Is it equal to? And it's specifically when we're comparing two values, are they equal? If I'm putting a value into something, it's that single equals, and that's something that catches people out quite frequently. So just be careful. It's very easy to, in an if condition, for example, to say if something equals something else, and you put a single equals in there, and it'll throw an error. Or it may just keep going through because it has managed to succeed in setting that value. But the key thing to remember is that if it doesn't work, then check that it's a double equals that you've used. Now, quite often we want to change the value, so we're not setting it to a specific number. Quite often it's usually adding or taking away a number or something like that. Now, if you were doing a loop, you might want to keep a counter, for example, of how many times it's gone around the loop. If you are keeping a score, you might want to add one each time something hits something else, or you get an answer right to the question, or whatever it is. So in Python, if I want to add to an existing variable, we use the plus and equal sign together, which adds it to whatever was in there to begin with. So if the score, you know, on the screen here, my variable is called myvar. If that was on 8 and I did plus equals 1, it would then go to 9 because it was 8 plus the 1 that you've just added in. So whatever is in there, it will add in. Now, there is a big red note underneath that you cannot add to something that doesn't exist. So in Python, even if you want to start it as empty or just to start it as 0, before you start your loop or whatever it is, use the assigning one, the single equal sign to set it up to begin with. So in one case, so if you were keeping a score for a game, you have score equals 0 at the start, and then later on, if you get an answer correct and you want to add a point on, you would use score plus equals 1 to add that point on. But because it was set up with that score equals 0 to begin with, it exists already. Okay, so make sure when you're starting your game, you set up your variables to begin with. So moving on, so the loops that we might come across. So there's two types of loop. There is the while loop, and then there is a for loop. And there's a very kind of clear difference between the two. The while loop happens while a condition remains true. So if you think about it in terms of maybe an age, while my age is less than 18, so, you know, and if you're age 17, that would be true. If it's less than 18, 17 is less than 18, then maybe the stuff that happens inside it while it's going around is that you're not allowed to drink, for example, or you don't have a vote or whatever it is, okay? So in human terms. But once I hit 18, that bit is no longer true. So then maybe it won't stop that from happening. Okay, so the while bit means while it is true. Now, the most common block, or one of the most common blocks that we used in Scratch was the forever one. And we can quite simply recreate that by just saying while something is true. So just while true, because that will never change, and it will then keep on doing whatever's inside it forever. Don't forget though, because it happens inside that while loop, everything you want to happen while that condition is true has to be indented. You'll see the little green arrow there just to point out that it's been pushed in. It's indented inside that loop. So that's the while loop. It happens while something, and it will continue forever. It doesn't have a fixed amount of times it does it. It just happens all the time until that condition is met, is no longer met. Repeating is very slightly different in the sense that it will repeat a certain number of times. So the repeat block in Scratch has repeat, and it's got space to put a number in. And it will repeat in that case, it will repeat what goes inside that block 10 times, not 9, not 11, exactly 10 times. It is possible to use things like a break clause to break out early if something specific happens, but in most cases, you will go through it each and every time, that amount of times. We saw it earlier on, the Python code for it, and the Python code for the repeat part is that for I in range. Okay, the range generates the number. The for I in bit is the bit that actually is the repeat element of it. Okay, so you can see that 10 is the number of times I'm going to run through that loop. Now, if I look at this as actual code, so in Python, the for is the keyword for repeating. Okay, the I in range bit, I is just a variable name. What it does is it keeps a record of the record that the item that you're up to. If it's a list of things, it will keep the item in the list. If it's if you're going through a certain number of times, it'll count up the number that you're up to. But essentially, it will kind of keep a record of each one that you're going through. The in then says is basically the bit that says in how many items. Okay, so the number of items that we go through. It can sometimes be the length of a string, for example. So you might want to loop through every letter in a string, or a sentence that somebody's written, maybe to, I don't know, take out all the letters I in a string, or to change all to capital letters, or whatever it is. But that is a number, and it will go through that amount of times once for each one. So in this example, we've got for a var name, a variable name, in, and then the number of items that it can do. Now, range just generates that many times of a loop. So if I want to do 10 times, I would do for I, or for j, or for k, or for my var, but whatever you want to call that variable, you can do for something in, and then the range being 10 would do it 10 times. So if I just take out some of those blocks, you'll see for this item, this item is the variable name in range, and then the number that goes in the range. So it could be, like I say, the length of a string or whatever it is, that tells it how many times it's going to go through. And then I can do print this item. So that means it will print, if it's counting up numbers, it will count up, and it will kind of print in your console, it will print the number that it's got up to, and you'll get a 0, a 1, a 2. And don't forget, most things, when we're talking about counting up, it will start at 0. Okay, indexes in programming start at 0, and 1 and 2 and so on. And it's just something you've got to be aware of, because sometimes as humans we're used to things starting at 1. Okay, so conditions work in a very similar way to many other things. The indentation is possibly the most important part of it. We're used to using if conditions in Scratch, where we have if, and then the bit that goes inside the block is if that is met, if that condition is true, then we do what's inside it. So in the example you can see on the screen, it says if the score is greater than 20, then show a message saying, wow, great score. If we look at Python and how that's coded, it is very similar. If the score is greater than 20, so if, and then the condition, score greater than 20, we have a colon at the end of the line before we start a new line, and then we indent, because what happens if that condition is met has to be inside that, so we indent and go in. Okay, so we then print to say, wow, great score. Now, in many cases, we want to do things, if it's not met, we do something else. And this is the key word there is else, that we can do other things. So if we look at an else condition on there, we come back out of the indentation, use that keyword else again with a colon at the end, and then what you want to happen in every other circumstance. So when the score is not greater than 20, then we'll print a message saying keep trying. So we can have conditions there that say if the score is greater than 20, do something, otherwise or else do something else. Now you can also have stages in between where maybe you have, if the score is greater than 20, print wow, great score. If the score is maybe less than 10, maybe say a message saying, are you even trying, or something like that. So for that case, in between, you might have an else if part that would have a bit inside. So you can combine else and if to have stages in between, but else on its own means anything that's not covered before it in those if statement or else if statements. Let's look at random numbers. So random numbers. So to get a random number in Python, we have to use what's called a library. Now, libraries are available for a whole range of different things, and Python basically gives us the opportunity to use bits of code that are pre-written for us, but to try and keep the programming to a small size, it doesn't include them normally, because not every program that's written needs a random number, for example. Not every program that's written needs to do data analysis using AI, or needs to use Turtle to draw a shape, or whatever it is. So all these things that have lots and lots of code to go with them to do things, we can pull in as and when we need them. If you think about it in terms of going to school, would you carry around all of your books for every single lesson, even if you didn't have a lesson on that day? You wouldn't. You would carry the books that are relevant for that job and that day that you've got. Okay, so to save you carrying the weight. And it's kind of the same thing with programming. We want to keep it light, we want to keep it manageable, so we only use the things that we need. So to pull in a library that's been written for us, we use the import command, and it just goes at the start of our program. So import, in this case, random, goes at the very start of the program. And then we can later on use that library to do some of the functions that are in it. In the random library, to generate a random number, a random integer, a whole number, we can do random dot randint, random integer, randint, and then in brackets we just put the from. So maybe between 0 and 10 would be from 0, and then comma 10, so would be the 2. Okay. So we end up with a total bit of code, as you can see at the bottom, random dot randint, in brackets 0, 9 would generate a random number between 0 and 9.